Hey everyone. So I'm here today to talk to you about a weird journey in Flexbox, some weird things we can do with it that I encountered on the way towards what I think is one of the CSS holy grails, trying to create a Masonry layout. So before that, quickly, my name is Tobias Ahlin, as you heard. I've spent the last 10 years working for these companies, and I care a lot about design and tech, and especially where they meet. And that's sort of driven this talk. That's why I love Flexbox and talking about it. And I love to actually start by just speaking to all of you and hear your names. It's going to take a long time, though, to go through every one of you and introduce yourselves. So I want to try something. What if we just, on 3, you all just say your name out loud at the same time? Okay, so let's try it. Okay, 1, 2, 3. Cool, nice. Nice to meet you all. So let's talk about Masonry and why it's difficult. So Masonry, as defined by David DeSandro, who made the very popular JavaScript Masonry framework, put it like this: placing elements basically in an optimal position based on available vertical space, not horizontal space, sort of like a mason fitting stones in a wall. So if we think of a wall and then we flip it, that's basically Masonry layouts. So you might have seen this on, for example, a lot of portfolios like Christian Hammerstad, or on Pinterest, right? Where it's a beautiful and great way to create an experience where we engaged and want to explore. So this is a great layout, but it's difficult to create with CSS. And this question has traditionally, or the answer to this question has traditionally always been not really possible. And that's because, so when Flex came around, it looked promising, we got some new fancy tech. But as it turned out, it wasn't really enough. So the problem is really that with a Masonry layout, we've got dependencies running top to bottom, right? So the top element will affect the position of the element below it. But as users and as people, we parse left to right. So the order or sorting has to be rows, but the rendering has to be columns. So with Flexbox, it usually looks something like this. So if we have a container and we just put in some placeholder elements, I'm back. Great. So if we render this as a row with flex direction row, what we get is something like this, where if we have varying heights of the elements, we'll get weird gaps all over the place. So it reads left to right. That's great. But everything's grouped into rows. So, and the height of each row is decided by the tallest element in that row. So we can't use that. Then we have to use columns instead. So if we change the X direction to column, and we get a render that looks sort of right. But the problem is, of course, that now everything reads top to bottom. So the third element is down in the corner. The 10th element, if it's a real long page, could be totally out of view, and that won't really do. So what we're going to do is, the problem is that the CSS spec has really, from this point of view, conflated two concepts, sorting and rendering. And so we need to figure out a way to do that, to render items as columns, but sort them as rows somehow without the spec really allowing us to. So here's the solution, or the code that brings us there. First of all, we have to use columns. Then we have to use nth child and order to actually resort everything into rows. And then we need to use a Flexbox clear line hack to force things to be in their correct columns. So these can actually be pretty useful in some other scenarios. So what we're going to do is we're just going to go walk through this, why it works, and look why you can use it or how you can use it in some other projects. So this is going to enable us to create this sort of layout, where we have dependencies running top to bottom, but the sorting left to right. So let's start by looking. We're going to look at two concepts. Oh yeah, one caveat here. Because of how Flexbox works, we have to have a fixed height for the container. We can set that with CSS, but if we have a responsive site that we should have, we need some JavaScript to fix this. But at least we will, with this, be able to create a solution with minimum JavaScript rather than an entire library that does everything for us that could also be pretty slow. So we got two techniques that we're going to walk through today. One, it's stacked ordering. That's basically how we can reorder things dynamically. And one is Flexbox line breaks. So let's start with stacked ordering. Now, as we talked about, we can't really use rows. So this is not a viable starting point. But what we have to do is we have to start with columns. So if we render things as columns, again, they run from top to bottom. How do we change the sorting? There are no real property that can do all the work for us. We've got like column reverse and row reverse, which just reverses the ordering, but that's about the can actually affect, thank you, the ordering. So there is the order property, and it basically works like this. If we have 4 elements, for example, in a list, and then that may look like this. We target the third element, and we set order to -1. That's going to move that element to be in the first position in that list. So that's great. Theoretically, if we just realize that we've got control of the order of all the items, we know that we can figure out a way to use it efficiently to actually create the layout that we need. The question is, how do we even do that? What order are we looking to create, and how can we get there? So if we start by looking at a table, and we render this as rows, the ordering is naturally going to be left to right, 1, 2, 3, 4, 5, 6, 7, 8, 9. If we then render it as columns, we're going to get vertical ordering with 1, 2, 3 running top to bottom, 4, 5, 6, 7, 8, 9. If we pretend that we have this render, but the sorting is left to right, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's what we want. Then we just look at how it's actually sorted. So we can see here that it actually sorted per column 1, 4, 7, 2, 5, 8, 3, 6, 9. In other words, the default order is 1, 2, 3, 4, 5, 6, etc. The order we want to create is 1, 4, 7 for the first column, 2, 5, 8 for the second, and 3, 6, 9 for the third. Basically, 3, 1 plus x, where x is the column that we're targeting. Now, setting the order property for every individual item doesn't really scale. It's not a great solution. This is really hard to parse. You will quickly outgrow this, of course, with more content items. But there's the cool thing with order, which is that if you set the same order value on multiple items, the order falls back to the source code order. Okay, so if we return to this example, and if we this time target both the third and the fourth item, and we set -1, what's going to happen is that they both, of course, are moved to the beginning of that container. But the order of the third and the fourth item is decided purely by the source code order. So the third item is before the fourth, and they're kept that way. That means, of course, that we can create this layout with just one order value per column. And the source code order will just handle the rest for us. So we can do that by using nth child and use the algorithm that we talked about before. So let's just start by painting out and visualizing which boxes we want to select. So if we do this and return to our table, we can call the first 3, or every third with an offset of 1, red. And then we can color the other ones blue. And then the third selector with yellow. Okay, so if we then take these and replace them with order. So we've got order 1, order 2, and order 3. We can see now this is before the reordering actually happens. So if the order 1 is the first row, order 2 is the second row, order 3 is the third row, and then this is what happens after the fact, right? We just order everything as rows. So we got 1, 4, 7, 2, 5, 8, 3, 6, 9. So we created the order that we're after. This scales really well with infinite amount of items. We got order 1, order 2, and order 3. Now, this is cool, but there's a problem with this solution. Everything can break. It's not great. So everything can break because Flexbox behaves like a cat. If it fits, it sits. All right? Flexbox really want to push items into any sort of gap that it can find. So this is a problem for us, because remember, things are rendered top to bottom. And then we've got this layout. We got a big gap here. So in the second column, we got 3 shorter items. So it looks really like there's a space here for the third item, right? And yes, it is. So it behaves like a cat, and it sits there. And it's really screws up the entire layout. Now we got 1, 2, 6, 4, 5, 9, 7, 8, 3. Ridiculous. So we need a way to line break or clear things with Flexbox. Problem is, Flexbox doesn't come with a line break thing as a concept out of the box. You can't say this item should just be after a line break or you should line break. So let's talk about that. Let's talk about how we can bend Flexbox to actually do that. So Flexbox line breaks. If we take a step back, look at a different layout. If we want to create something like this with 2 rows, a typical way of doing that is to just set the width or the flex basis for every item. If we don't do that, all the items would just squeeze in on one row and nothing would make it wrap to a new row. Something that's annoying with this is that if you then decide to add things to this layout, like we add an item on each row, we can't have the same widths defined, right? We have to redefine everything. So now every item has to be 20% on the top row, and on the second row, everything has to be around 33%. So what if, as a concept, we could just define the flow of items rather than the width of all items? So we can get rid of all of this, and then maybe we could just say we want 5 boxes, and then we want a line break, and then we want 3 more boxes. Now, there's a way to do this. We can do it something like this. We have to use an HTML element. Here, I've called it just break. So we've got 5 elements. We break, and they've got 3 elements. And the break basically looks like this. It's real easy. Flexbox is 100, height 0. You don't have to have margin 0. I have it because I have other styles on the break. They will affect it if I don't reset it. But this basically collapses an item and make it full width. Now, conceptually, this is equivalent to a BR, which isn't great, or setting clear on an element. But that's what we have, that's what we've got to work with. With this, we only have to define flex grow on all of the items. So they need nothing. They don't need the width. They just need flex grow, and then we have a break, and then we can create pretty interesting layouts. Now, just up front, CSS Grid is probably a way better alternative to create solutions like this, but now we're stuck with Flexbox, so we have to figure something out. So how does this work? Well, if we have just one flex item, and we have it set to flex grow, it's going to take up the entire width. If we add another one, they're going to share that space. If another third, they're all going to share that space. What happens now if we target the second item and we set width 100%? What happens is that item is going to put itself on its own row. The other 2 items are going to grow. And then we've got 3 items, 1 taking up a separate row. Now, the trick here is just to collapse this item to height 0, and then we've got a line break. It works. So Flexbox line break is pretty easy. You just insert an element and you collapse it. So with that, we can create pretty complex and interesting layouts, but we don't have to worry about the width of any of the items. So what we can do is we can put all this together. And we can create this. And remember, this is the problem that we had. So Flexbox with 3 short items here. The third one is going to move here. We can instead introduce these line breaks in between every column, and it's just going to work out. They're going to stay put and not overlap or overflow into each other's columns. So remember, this is our HTML. How do we insert the breaks at the right place? The order that we've created is really this. So 1, 4, 7, 2, 5, 8, 3, 6, 9. What we want to do then is in these columns. So we can use pseudo selectors and produce some pseudo elements, for example, for this solution. And remember, those are going to be as before and after all the other children. So what we can do is we can target those, and we can set the order to 2. That's going to put it after the first row and after the second column. And they're going to divide our column or Masonry layout into 3 distinct parts. So the full solution, again, is this. We have to use column. We have to make elements wrap. We then target every third item. That's depending on how many columns we have. The offset is the number of the column. And then we insert the clear line hacks. Now, we can work with more than 3 columns, but then we have to abandon the pseudo selectors to do something else. So in that case, we need to replace pseudo selectors with spans. There are 2 different ways of selecting children with nth of. There's nth of child, and there's nth of type. So what we need to do is we need to put the line breaks at the very bottom, or at the top, it actually doesn't matter, but you put them somewhere, and you use a different element than you use for content items. So if you have divs for content, you need something else for the breaks. Because what we're going to do is we're going to use nth of type this time around to create 4 columns. And using nth of type will count content items separately and independently from spans, so that the number of content items doesn't affect the positioning of the breaks. So this is, I think, is a great use case for exactly this. But if we, for example, had 10 content items in 4 columns, and then we used just nth of child, we would insert the breaks after the third, fourth, and first column and leave the second and third one without a break. So with this solution, we can create something like this pretty easily. But again, of course, for all of these solutions, we do have to calculate the height of the content columns with JS somehow, and then set the container height accordingly. The best thing, of course, would also be to calculate the optimal position for each flex item and set the order property accordingly. So often we can end up with layouts like this, where we have 1, 2, 3, 4, 5, and 3 is really big, which means we should not put the 6th item here. That's not how you parse this document naturally. You would want to have the 6th item to the far left, right? So we have 6, 7, 8, and 9. CSS doesn't bring us there. We'd have to do this with JavaScript and measure where every single column ends before setting the order property. But I think the cool thing is that we can do this. So I hope with this sort of exploration that 1, you found some cool tricks. 2, that maybe you're encouraged to build your own Masonry layouts. And there are a few, actually, that are using this technique out already. The first one that I saw is from Gilbert Pilgrim. He took this, basically, this technique, wrapped it in some very thin JavaScript, and now we have a very performant Masonry library that is way faster because we just put the rendering onto the CSS stack, because that's what CSS is great at, and then we do some other logic ourselves. But so hopefully, with sort of this exploration, it's become really easy to do exactly this. Now, I got some complaints about misusing Flexbox, basically, the first time I blogged about this. You can read all the blog posts here. Here's one, the blog post about Masonry, which is everything we worked through. Second, the line break hack. 3, a code pen collection with just everything, so you can copy and paste things. But there's something that excites me about Flexbox and why I spend so much time to this, and it actually connects back to Minecraft. So, excitingly, I think the CSS spec and all the work that we're doing within the web community is not just living in a silo within. Also, thank you, living in other places like third-party UI frameworks. So the really cool thing with the web spec is that a bunch of people put a lot of time into standardizing ways to build UIs. And with Minecraft, for example, we worked on actually bringing the web spec into the game, but not necessarily the tech. So in Minecraft, we embedded, the last few years, basically a thin web browser. But it's not a standard web browser. It's just built, it's a third-party UI library built according to the web specs. Which means that suddenly we can, as web developers and people from the web community, start developing UIs and games real efficiently because we're used to the way of working. But that means also, of course, that sometimes the spec isn't always what we're looking for. So I was motivated partly by that. We didn't have CSS grid in there. I wanted to explore ways of creating layouts that we'd need. And now the web is everywhere, including in Minecraft. So I wanted to explore that realm too, where there is no thing as CSS grid at all. Yeah, I hope you found this useful. That's everything for me. Thank you all. Thanks for listening.